Friends, today we will discuss the eigenvalues and eigenvector for the matrix A and A square and A inverse. We will also find out by taking A to the power n, right? What is the matrix A? A is the symmetric matrix. This 2 minus 1 minus 2, 1 and 2. A square is 5 minus 4 minus 4 5. What is the trace of this matrix? Trace of this matrix is 4. And when we find out eigenvalues for this, we will take firstly mod of determinant of a minus lambda equals to 0. Then it will become 2 minus lambda minus 1, right? What taking determinant of this will give lambda 1 is equals to 1 and lambda 2 is equals to 3. So it will be proved by that trace of a is also 4, and when we take the sum of the eigenvalues, this is also 4, and determinant of this is 3. Determinant of this is 2 to the 4 minus 1, it is 3. So the product of this will give the product of the eigenvalues gives the determinant of matrix, and the sum of the eigenvalues gives the trace of a. Find out the eigenvector for a. For eigenvector, we will take a minus lambda I. For firstly lambda 1 is equals to 1. This will give 1 minus 1 minus 1 1, right? This is this. For this x1 is 1 and 1. Why it is 1 and 1? When we take, we will have to prove that a minus lambda I of x equals to 0, right? We will want 0. For 0, we will take as x that will make matrix 0. So firstly we will take 1 of this vector and 1 of this vector. This product of 1 and this vector and the product of this one becomes 0. 1 minus 1 it is 0, 1 minus 1 it is 0. Now for x2 is for lambda 2 is equals to 3. When we take lambda 2 is equals to 3, this will become matrix will become a is equals to matrix will become minus 1 minus 1 minus 1 minus 1, right? For lambda 2 is equals to 3, this matrix. So the eigenvector is 1 and minus 1. Why? Because when we take 1 of this vector and minus 1 of this sum of this is 0. Okay, so this is x1 and x2 for eigenvector for a. What is the eigenvalues for a square? The eigenvalues of a square is lambda 1's whole square is given the eigenvector of this eigenvalue of this matrix A square matrix, and the lambda 2 square gives the eigenvalue for a square. Now for eigenvalues for a inverse is lambda 1 inverse is equals to 1, lambda 2 inverse which is equals to 1 by 3. For eigenvalue for a to the power n, which is given by 1, lambda 1 is 1, lambda 1 की power n